Welcome to this problem solving session. This is Okezie Chedozie from Special Maths Academy. In this video, we are going to be solving question 2 from 2021 Senior Maths Olympiad first round. We're told to simplify log base 6 of 400 over 243 minus 2 log base 6 of 50 over 9 plus log base 6 of 75 over 4. In solving this question, we are going to make use of some laws of logarithm. The first law we are going to make use of is the one that says that log A plus log B is equal to log AB. The second law we're going to make use of is the one that says that log A minus log B is equal to log A over B. And the third one that we're going to use is going to be the one that says that x log A is equal to A raised to power x. I'll just call this law 1, call this law 2, and I'll call this one law 3. So let's dive into the question now. We're told to simplify log base 6 of 400 over 243, then minus 2 log base 6 of 50 over 9. Plus log base 6 of 75 over 4. What we'll do now is we'll write each of these terms in index form, that is as a product of powers of its prime factors. So this becomes log base 6. So 400 is 16 times 25, and 16 is 2 raised to power 4, and 25 is 5 raised to power 2, and then divided by 243 is 3 raised to power 5. So that's what we have for the first term. For the second term, we're going to have 2 log base 6 of 50 is 2 times 25, which is 2 times 5 raised to power 2, divided by, and 9 is 3 raised to power 2. And that's the second term. And then for the third one, we have log base 6 of 75 is 3 times 25, which is 3 times 5 raised to power 2, divided by 4 is 2 raised to power 2. And this is what we have. The next thing we're going to do now is that we're going to simplify the second term here, this one, using law 3. So the first term stays the same. We still have log base 6 of 2 raised to power 4 times 5 raised to power 2, divided by 3 raised to power 5. And then from that law, we have that x log A is log A raised to power x. I think this should be, so I think I should write this as equals log A raised to power x. Yes. So that's going to be minus log base 6 of 2 times 5 raised to power 2 over 3 raised to power 2. And since we're multiplying it by 2, it's going to be raised to the power of 2. And at the end, we have plus log base 6 of 3 times 5 raised to power 2 over 2 raised to power 2. And then on the next line, we're going to now simplify everything together using law 1 and law 2. And so we're going to have log base 6 of 2 raised to power 4 times 5 raised to power 2 over 3 raised to power 5. Then since we have minus log base 6 of this other term, it becomes divided by, and then we have, I'll just simplify the bracket here. I'll square everything. So that becomes 2 squared times 5 raised to power 4 all over 3 raised to power 4. And then since we have plus, here we use times. And then that part we have 3 times 5 raised to power 2 over 2 raised to power 2. Since we're dividing the second term, we can change the division to multiplication and flip the fraction. And I'll go ahead and write that here. So that becomes log base 6 of 2 raised to power 4 times 5 raised to power 2. So we're doing this just to the second term since it's division we have. And then the denominator becomes the numerator. That's 3 raised to power 4. And then the numerator becomes the denominator. And times, this one still stays the same. 3 times 5 raised to the power 2 over 2 raised to the power 2. Cool. So I'll scroll down a bit now. And then at this point, we're going to simplify the numerator and denominator. So we'll just multiply everything we have on the numerator together, and we'll multiply everything we have on the denominator together. Then after that, we'll see if things cancel out. So we have log base 6 here. 2 raised to the power 4 does not multiply anything above, times 3 raised to the power 4 gets multiplied by 3 to give us 3 raised to the power 5, times 5 raised to the power 2 times 5 raised to the power 2. That will give us 5 raised to the power 4. And on the denominator, 2 raised to the power 2 times 3 raised to the power 2 gives us 2 raised to the power 4. And 3 raised to the power 5 does not multiply anything, so it stays like that, times 5 raised to the power 4 does not get multiplied by anything, so it stays like that too. And at the end, we notice that everything cancels out. 2 raised to the power 4 cancels 3 raised to the power 4. Same with 3 raised to the power 5, and same with 5 raised to the power 4. And then this gives us log base 6 of 1. And the log of 1 base anything is always 0. So this is equal to 0. Which means that the expression we had at first is equal to 0, and option A is the correct answer.